In today's lesson, we are going to be looking at the volume of a pyramid and cone. Now, the reason we're looking at these two volumes in particular is because they do have some unique characteristics about them, especially with how they relate to prisms. So for the volume of a prism, right, or volume of a pyramid, we want to first look at the volume of a prism. And the volume of a prism, any prism, is going to be the area of the base times the height. So what we mean by that is, let's say maybe we have a square-based prism, or could be a rectangle. We're basically finding the area of the base, this area here, and then multiplying it by the height. If we had a different prism, say maybe it's a triangular-based prism, triangle at the base, measurements go up. If we find the area of this base and multiply it by the height, that is going to give us the volume. You can almost imagine, let me draw it again. You can almost imagine basically just adding in, so we find the area of the base, and when we multiply it by the height, it's like we're adding in another layer just on top of this, and then another layer just on top of that, and another layer just on top, another layer just on top, and so on until we reach the top. So we're basically adding up each layer every time until we get to the top. Now when we have a pyramid, it is the area of the base times height divided by 3. So there is a relationship between prisms and pyramids if they have equal dimensions. So if the area of the base and the height of a prism is equal to the area of the base and the height of a pyramid, right? So for example, let's just draw a square-based prism or a rectangular prism. So if I have this rectangular prism here, and if I have a square-based pyramid that is roughly the same height, has the same dimensions for the base, right? We're comparing those two. And what we're going to find is that the volume of the prism is going to be 3 times larger than the volume of the pyramid. And on the flip side, the volume of the pyramid is going to be 1/3 times the volume of the prism. And we can see that in the formulas as well, right? Area of the base times height, and area of the base times height divided by 3. So that is the relationship between a pyramid and a prism of equal dimensions. So again, for example, see if we look here, if we have a prism, right? We have a square, we have base, and height. We'll call this a square-based prism or a cube. If we have a pyramid, right, with equivalent dimensions, right? So base, same side, and we have our height here, right? Again, the volume of this prism is going to equal 3 times the volume of the pyramid, and the volume of the pyramid is going to equal 1/3 the volume of the prism. So if I knew either volume, I could easily find the volume of the other. Now for a cone is very similar, except instead of it being a prism, we're dealing with a cylinder, which is a prism in a sort of sense, because we have a base that is a circle specifically with a certain height. So in this case, the formula is the same, the general formula. We find the area of the base and we multiply it by the height. And a cone is like a pyramid, except it has a base that is a circle. And again, if we find the area of this base, multiply it by its height, right? The height would be going down the middle from the peak down to the base. We find that height, we divide, so area of the base times height, and we divide by 3. So the same relationship occurs in cones and cylinders. If you have a cone or a cylinder that has a certain area and a height, and it's equal to the area of the base and height of a cone, then we're going to find that the cylinder, or the volume of a cylinder, is 3 times the volume of a cone, and the volume of a cone is 1/3 times the volume of a cylinder. So similar relationships as we just saw with prisms and pyramids as there are with cylinders and cones. So again, imagine we had a height, we have a base or an area of a base. We'll say we have a radius, because we do need some sort of dimension on the bottom that would be similar. So say we have the radius, and the radius of the cone would be the same as our height. So again, we would have the same kind of relationship. The volume of the cylinder is going to equal 3 times the volume of the cone. And the volume of the cone is going to equal 1/3 the volume of the cylinder. So same relationship that we just saw with the prisms and pyramids, again with cylinders and cones, which is another type of kind of prism and pyramid. So let's use these examples, right? So the first example we're going to look at, or let's use these ideas and let's kind of go through and find the volume. So the height of a square-based pyramid is shown as 7.5 meters. The length of the base is 10 meters. We want to determine the volume of this square-based pyramid. Right? The volume, or the base, is a square base, so we can assume that all sides are the same, and we're told what the height is. Now, if you look at your formula sheet, you do have a formula for a square-based pyramid, but if it was a unique base, or if we had something different, right, we might not be able to find the general formula or find the formula on our sheet. However, if we do know the general formula for volume is the area of the base times the height, and because it's a pyramid, we're then dividing by 3. As long as the base is a basic shape or one of my common shapes, I can find the area of it. So in this case, the area of a square is base times base, or base squared, or side times side, or side squared, times the height divided by 3. I know that b is 10, so 10 squared times 7.5 divided by 3. I get volume is equal to 100. Don't forget to bed mass says we squared first and then multiply. So 100 times 7.5 divided by 3, and we get a volume is equal to 250 meters cubed. B is now asking, what is the slant height? What is the slant height of our square-based pyramid? Now, the slant height is not the height of our pyramid. It is actually the height of the kind of triangular faces. Right? So the slant height is this measurement here. So it's the height of one of the faces. And it is going to be different from the actual height of the pyramid. And we can solve for this, because if we imagine that the height of the pyramid, or the length goes right down to the middle and forms a 90-degree angle, if I go over from that slant height to my edge, or to the edge of the pyramid, it actually forms a right angled triangle between the height of our pyramid, you could say the radius, or half of the side length, and the slant height. So half the base. Right? So I actually have enough information to find that slant height if I'm given the height of the pyramid and the length of the base. What we actually have is we have a height of 7.5. Oops, a little too big. We have a height of 7.5. We have half the base, which would be 5, and we're looking for the slant height. And if we want to find that, we have the sum of squares, or Pythagorean theorem. A squared plus b squared equals c squared. That slant height is the hypotenuse of this right angle triangle, or c. So I know a and b are going to be the two legs, or the other two values. Doesn't matter which one. So 7.5 squared plus 5 squared equals c squared. 56.25 plus 25 equals c squared. Don't forget to square, which means multiply it by itself. We're then going to add them together. 81.25 equals c squared. And we want to get c by itself, so we have to square root at the end. The square root of 81.25 equals c. And we get roughly 9 as our slant height, or our c value. Right, so therefore, the slant height is 9 meters. And this would be useful because if we did want to find the surface area of a pyramid, we would have to have this value because we would need to find the area of these triangles. So this slant height would be the height of the triangles, which we would need. In some cases as well, we are also given the slant height of a pyramid, and we would need to kind of reverse calculate or use the sum of squares to find the height of our pyramid or one of the legs. Like if you think about a pyramid, think about the Great Pyramids in Egypt. If we wanted to measure the height of the pyramid, it might be hard to go from the middle all the way down because it's full or it's locked up or it's a solid pyramid, right? And we don't want to drill through from the top all the way down. So we would be able to measure the base. We would be able to measure the slant height because it's outside. The height of the pyramid we could then calculate using sum of squares. Example 2, the height of a tetrahedron shown is 4 feet, and the base, or the length of the base, is 5 feet. So maybe not the most accurate diagram, but the length, or the height is 4, the length is 5. We want to determine the volume of this tetrahedron. Now, one thing to keep in mind, we need to find the area of the base first, right? We need to find this area. Now, unfortunately, we don't have enough information right now because we need the height of this triangle, the base. I need to find the height of that first. So step 1, we're going to find h. And if we think about it, right, I can use sum of squares because I do have a right angled triangle here. The only thing is, though, I'm missing a few side lengths. Right, so if I'm just going to draw this off to the side. I know that it's an equilateral triangle, so I know that this side is going to be 5. Right, these sides are all 5. I don't know what the height is. The base, there's a unique property with an equilateral triangle. If we draw a perpendicular line straight from a point or a vertex all the way down to the other side, it forms a 90-degree angle, and it also divides the opposite side in half. So what that means is that this base of half of this is actually going to be 2.5. So now I have enough information to actually find my unknown leg, or h. So a squared plus b squared equals c squared. 2.5 squared plus, we'll call it h now, h squared equals 5 squared. 6.25 plus h squared equals 25. I want to get rid of the 6.25, so I'm going to subtract it from one side, subtract it from the other. H squared is equal to 18.75. Again, last step of anytime we're using the sum of squares, we should square root. So h squared, or not h squared, so h is equal to the square root of 18.75, or h is equal to 4.3 feet. Now that I have the height, now I can go through and find the area of the base and then the volume. We're going to find the area of the base. You could combine these next two steps if you are more comfortable with the volume of a pyramid formula. But we'll break it down into two steps. So we're going to find the area of the base. So area equals base times height divided by 2, which equals 5 times 4.3 divided by 2, and we get an area equal to 10.8 feet squared. Now for 3, we're going to find the volume, and volume is equal to the area of the base times height, all divided by 3. So the area of the base we already found, we just found that in the last step, 10.8 times the height, which we were told in our question is 4, divided by 3, and we get 14.4 feet cubed. So therefore, the volume is 14.4 cubic feet. Right, so some more steps to finding volume that you might have anticipated, right? It's not just sometimes just a formula that you can plug in, especially if for these pyramids or prisms, you're given a base that we don't have the formula for. Right, you might not have a triangular base pyramid on your formula sheet, but you do have enough information knowing the general formulas and knowing the formulas for some of the basic shapes to help find the volume. One last example, if a cone had the same height and diameter as the cylinder shown, what would the volume be? So we do have that relationship at the beginning that said if we knew the volume of the cylinder, a cone of equal dimensions would be 1/3 its size, right? So let's find the volume of the cylinder. We know the general formula is the area of the base times height. The base here is a circle, so the formula for the area of a circle is pi r squared, and then we're going to multiply that by the height, or h. Pi is 3.14, or you can just use the pi button. R represents the radius, which is half of the diameter, or half the distance across, or from the center out, so that's the radius. I'm given the diameter, I'm given that entire thing. The radius is going to equal the diameter divided by 2, or 14 divided by 2, which is 7. So in our formula, we're going to use 7 squared times the height, which is 23. I could do this all on a calculator. I'm just going to show one extra step. Remember, when we square a number, we multiply it by itself. So 7 squared is 49. And then I'm going to do pi times 49 times 23. And we get a value of 3,540.57. This would be centimeters cubed. Now, if you use 3.14 instead of the pi button, you might have gotten a slightly different answer because 3.14 is just the rounded version of pi. We learned all the way back in the beginning of the unit that pi is an irrational number, which means the decimals never end. So by rounding, we are going to get a slightly different answer. Now, for the volume of the cone of equal dimensions, we can take the volume of the cylinder and we're going to divide it by 3. Or 3,540.57 divided by 3. And we get a volume of 1,180.19 centimeters cubed. Therefore, the cone would have a volume of 1,180.19 centimeters cubed. So even though we probably have the volume formulas for some of our prisms and pyramids, this lesson kind of shows us the general formulas, which means as long as we know the area for the base or the area for the shape that the base of the prism or the pyramid is, we can go through and calculate the volume. And for a pyramid of similar dimensions to the prism, it's 1/3 its volume. And the same thing goes for the cones and the cylinders. So just some general kind of properties that we could look at that will help us find the volume of shapes.